Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to Technical Session 5C. I'm Pranjal Banage, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today, that is 9 July 2026 in Goa, India, and the virtual event is being held through Zoom from 9 to 11 July 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for questions and answers. In 8 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then I'd like you to write it to me and or the co-host in the chat box. Now, I would like to introduce our session chair for this session, Professor Ganesh Bhatkar. He's a professor in the Department of Computer Engineering at Vishwakarma Institute of Technology, Pune, India. With around 20 years of academic experience, he has published approximately 30 research papers and actively contributes to the research community. His core areas of expertise include human computer interaction, medical usability, artificial intelligence, and assistive technology. Sir, I would like to invite you to give a few opening remarks.
I hope you are able to hear me and can you see me?
Yes, sir, you're audible,
I
but
don't
I
know.
don't think your video is turned on.
Exactly, it is not turning on. I'm not sure what has happened.
So we can see you now.
Yeah, now it's okay. Okay, so myself, Dr. Ganesh Bhutkar, I'm from VIT Pune, and I welcome you to this session. I think there are 10 papers, right?
Yes, sir, there are 10 papers.
Okay, so please stick to the time and we'll have a question answer session in the after each paper. So I think we should start. We welcome you all, and we can start directly.
Yes, sir.
Thank
Okay,
you.
thank you. Now we'll be starting with the session. I'd like to invite Musakalim Khan to present his paper on a hybrid deep learning chaotic crypto system with fingerprint driven key generation for secure CT image transmission. I apologize if I mispronounced your name. You can start with your presentation.
Good afternoon, everyone. I am Musa Kalim Khan, and today I'll be presenting our work on a hybrid deep learning chaotic crypto system with fingerprint-driven key generation for secure city image transmission. Okay, so this work is with my co-workers from Maulana Abul Kalam Azad University. So I will walk through this three part first for my presentation roadmap, and there are we have first problem solving and a quick look to the existing approaches where they fall short, and third the bulk of my time our proposed method, it's the result and what makes it different from the other state of art methods. Now coming to my introduction part, so let's start with why this problem matters. City images are routinely set from hospital to cloud and IoMT platforms, remote diagnostics, telemedicines, and each of these images carries highly sensitive patient information. And any breach directly threatens both privacy and diagnostics integrity. Now, the traditional cryptography like AES and DES is mathematically strong, but the images are not text. They have a huge spatial redundancy. So, so standard cipher modes uh, so can be so standard cipher modes leave visible structures in output. That's a real weakness for medical image specifically. Now, the second issue is the authentication. Even the best chaotic encryption schemes today are very single factors, like they are like same symmetric keys for encryption and decryption, but there is no biometric keys. Regardless who you are, there is no binding to the actual patient or an authorized person who is access on the city image. So our motivation is very simple. We are building an encryption system where the decryption key itself is tied to leave biometric identity, so that even a stolen key is useless without a right person fingerprint. Now we are moving towards the literature survey and research gaps. So looking at the PDR work, use-based schemes like Arnold and logistic maps giving strong statistical security, but have zero authentication. And other systems like deep EDN or deep keygen improve entropy, key space using generative adversarial network. But again, the model are very heavy and it does not compatible with IOMT devices. And if we implement that, and also there are no biometric authentication there. Only one only one there is an paper where they use biometric, but they only encrypt the region of interest, like where is the diagnosis happen, only there that part. So we want we want to encrypt the whole city image. So that are the our research gaps. Like there are no biometric keys in key generation and heavy deep learning models, and there is some lack of cryptanalysis. Like many of the papers doesn't calculate the NPCR USA entropy. So we want to ensure that all these three things can be covered by our system. So now, what is our proposed method? Here is the big picture of our system, and it has three components working together. One is image CNN that converts a fingerprint image into a 128 dimensional embedding. Two, a key derivation model that binaries the embedding system and has it with salted SHA algorithm into a session key. And last but not least, a two-stage image cipher where Arnold transformation for confusion followed by a Zod diffusion using a key stream derived from the same hash key. The key idea is that encryption key is never plain text derived or static secret. It's generated fresh from the person fingerprint. Every session using a random salt. That means identical fingerprints produce differential keys each time. So even the fingerprint template itself is never stored or exposed. Now we are going through this Siamese CNN architecture. This is an this is the authentication core. The Siamese networks takes two fingerprint images through identical weight share branches, extract feature vectors, and computes the Euclidean distance between them. If the distance is below our threshold, that is, we assume that is we store here that is 0.5 in our experiment, the fingerprint is verified and we proceed to our next further decryption process. If not, then the decryption is rejected. This is a trend using contrastive loss. So genuine pairs from the same subject are pulled close together in embedding space, and imposter pairs are pushed apart. And once the trend we freeze the network and reuse it for both key generation during encryption and verification during the decryption. Same model, dual purpose. Now, coming to our decryption pipeline, the decryption is similar to the encryption, but it's a mirror side. Like that, there is a hard gate in front that tests the fingerprint must pass the Siamese verification and regenerate the exact same hash key before anything else happens. Only then we invert the Zod diffusion, reverse the Arnold transformation, and recover the original city image. If the fingerprint doesn't match, the system returns to authentication failed. No partial decryption, no leakage. Now, what data we use? What data set you use? For evaluation, we use public test image that is available on Kaggle, and for fingerprint to train our Siamese CNN, we use SocoFing fingerprint dataset that has 6,000 rolled fingerprint images from 600 subjects. We train the Siamese network with some genuine and imposter pairs, and so that we can see that how effectively it works. And it's fully implemented in TensorFlow with NumPy and OpenCV handlings with some cryptographic operation. Now, that's our the result section, and this is where the framework proves itself. First, we will see that the entropy. The entropy of this image is 7. The entropy of the ciphertext is 7.9866, very close to the ideal value is 8, meaning the ciphertext looks statistically a random noise. Now, what we see the NPCR. What is NPCR? NPCR is like we are comparison between a original city image encrypted city image and a modified encrypted city image, and that is 99.63. So means that a single pixel change in the plain text called the ciphertext is completely different. And
I'm so
USCI
sorry
that
to interrupt, but I'd request you to conclude your presentation.
okay. After that, the result will go for the comparison table, and where I compare it with some of the state of art methods, and the biometric authentication and our proposed method gives a very good result. The comparison between these four papers. Now, the conclusion part. To conclude it, we built a framework that successfully integrates fingerprint-based authentication directly into the encryption pipeline. It uses lightweight Siamese CNN, and it light enough to implement in IoMT devices in future, and combined with that annual cat map, that chaos-based encryption is very strong statistical security, and critically our reconstruction quality is very good. That is PSNR around 30 dB, and SSIM, that is structural symmetry over 0.95. So it is clinically acceptable, and so diagnostic content is not degraded. And that's our future work, where we use this model to multimodal biometric fusion, real-time edge deployment, and we'll use some DICOM standard so that it can it can be used in real-time deployment in hospital infrastructures and some cross-modal experiment. And that's our references from I got the ideas and from where I get the papers. Now, that brings me to the end of the presentation. In short, that we have shown to trying encryption keys to leave revocable biometric identity, not just theoretical sound, but practically achievable without sacrificing image quality or security strength. And thank you very much. And I'm happy to take some questions.
Thank you so much, sir. Do you have any questions for him?
Yes. So thank you, Muskalim, for your
Yes, sir.
presentation. How you pronounce it? Muskalim.
Musa Kalim, sir.
Musa
Yes.
Kalim. Okay, okay.
Yes.
Okay, great. So I have a couple of questions. First thing is, you have used fingerprint. Have you compared other biometric techniques while selecting
No,
fingerprint as a security
no,
method?
no, sir. I just started it with fingerprint, and the future idea is with some face or iris, we can go for it because Simon CNN is built for uh,
Okay.
that.
Another thing is, in medical, there is an act which is called Digital Personal Data Protection Act. That is
Yes.
also called DPD, DPA. There is an act, okay, which protects the rights of patients or medical users in general. So, have you taken care of this? How you basically maintain the privacy?
See, sir, every fingerprint, a patient have their own fingerprint and have their own data. So
Hmm.
if a patient can encrypt their data with their own biometric, then then the confidentiality and integrity of the patient remains to him and to the hospital only,
Okay,
and no, not with sharing with others. So there is a privacy maintained here.
okay, okay. Thank you very much. Thanks.
Thank you so much for your presentation. Next, I'd like to invite, just a minute. Now, I'd like to invite Kushal to present his paper on AI based child malnutrition detection using transfer learning with MobileNet V2 and ShuffleNet V2. You may present your screen.
Yeah, yeah, sure, ma'am. Can you see the screen?
Yes, I can see your screen.
Is a presentation visible?
No, the presentation is not visible. I can see the Zoom screen. Hmm. We can see your presentation now. You can start.
Good morning, everyone. Good afternoon, everyone. Thank you for having me. Today, I want to talk about simple question. What if diagnosis malnutrition in a child was easy as taken as photography? Today, I'll walk through you an AI system we built that does it exactly using a two lightweight neural network called MobileNet version 2 and ShuffleNet version 2. Let's start with why this matter. Malnutrition is still one of the biggest threat to the child health worldwide. Nearly 45% of children dead under 5 are linked to some form of malnutrition worldwide. It is important to understand malnutrition isn't just a children being underweight. It shows up two form like underweight and undernutrition and overnutrition. In undernutrition, there are two types like fasting and stunting. If we talk about overnutrition, it is obesity. Millions of children are affected every year. Burden falls hard on low and middle income countries. The challenges are in today's world health workers rely on manual hands-on mobile method measuring a child's arm circumference with tape, cross-reference, wait for height growth chart, or running a full clinical survey. This method works, but They are clinical gold standard, but they all share same problem. They require trained staff, specialized equipment, and time. In rural or under resource communities or village, that combination is often simply not available. Screening doesn't scale. Our idea is Next is our idea. So ask, what if a photography was enough? We built an AI system that takes a simple photo of a child and predicts instantly whether the child appears nourished or malnourished. The process has three steps. First, community health worker take a photo with any smartphone. No special equipment needed. Second, and AI analyzes that photo uses two efficient neural network to recognize visual sign of nutritional status. And third, within a second, the system return a result along with a visual explanation of why it made that prediction, which I will show you shortly in the later. Literature. Before I show you our result, I want to place this work in context. Prior research has approached this problem from different angle. Lakshmi Narayan colleague has used the NN model with a child image of 500, reached 96 accuracy. And another approach, deep ENN, has 86 with a of data set of Bangladesh Health Survey. You will notice that most of this either rely on tabular survey, which are still some of collect detailed measurement, or on heavier model are not built for mobile deployment. As you can see, all are on survey data set. That's the gap we want to close. A lightweight mobile image-based model that accurately enough for clinical use and light enough to run on phone. Next, our data set. A real clinical photography of malnutrition raises serious ethical and privacy concern. So instead, we generated our data set with a stable diffusion model, creating 2160 images of children. Every single image was manually inspected and labeled. Our malnourished category deliberately include both extremes, like children showing visible wasting, children showing obesity. So the model learns the fully clinical picture, not just one side of it. In total, we used 167 training image for training and 503 images for validation. Next, we'll go how it works. The photo comes in, the pre-process like a resize standard, then pass through one of two neural network. Both were originally trained on millions of general images and then fine-tuned specifically for this task. Final layer makes call nourished or malnourished. Next, our two model. One is MobileNet version 2, ShuffleNet version 2. Are both were specifically designed for a mobile or embedded device for lightweight. That exactly the environment we care about. The community health worker smartphone, not a data center. We tested both to see which architecture handles this task best. And here's the result. Both model achieved around 97.97 accuracy on validation accuracy with an IASU of 0.98. ShuffleNet in the same close behind 96.95% accuracy with the AUC of 97. To put the ROC curve in the right, as you can see, as the orange closer to the top left corner, the better the model is telling nourished or malnourished children apart. Both of our do done very well. And critically, the precision, recall, and F1 score exceeded 0.93 for both classes across the best configuration. For context, this beat every prior research based survey I mentioned earlier, some of which topped out in the 68 to 75 range. Clinical reliability rarely misses a malnourished children. As you can see, the mobile net missed case rate of just 0.59, essentially 1 in 169 malnourished children in our validation set. ShuffleNet came in 1%. Both are well done level that would be safe for screening tool. Next, building a trust. One question I always ask, how do we know that AI actually looked at a real sign of malnutrition? This was where technique used called GradCam to create heat map, which part of heat map showing exactly which part of the photo the AI is focused on. For malnourished children, the model attends on torso and limb, as you can see in the image where wasting is visible. This picture is taken from a real-time image we tested on both the models. This confirms that AI looks at a real physical sign, not background clutter. If we compare from the peer-reviewed paper and our model, as you can see, it has what noticeable is just we have more accurate. It is what we got there using image alone, with architecture specially built on to run on everyday mobile hardware. Coming to conclusion, one, we have three takeaway. First one is single smartphone photo combined with lightweight AI can screen for malnutrition over 97% accuracy. Second, explainable AI, where explainable heat map lets the health worker verify and trust each prediction. Next, third, both models are light enough to eventually run directly on ordinary phone in field with no internet connection required. Looking ahead, our next step are to validate this in real clinical photography rather than synthetic one. Exploring combining health both model together, build this into an actual model application that community health worker can use directly. Thank you very much for your time. I would happy to take any questions.
Okay, thank you, Kushan,
Thank you, sir.
for your presentation. It's very important topic, child malnutrition. So I think you use some data set, right? And you said you have generated the images, right?
Yeah, we have generated using a stable diffusion model.
Okay, you have generated the images, and those images are something like 2000.
Yeah, it took lot of time.
Huh. Yeah. So how real they were? Right? They were very close to real.
Yeah, sir. It was we check some of them with from the real time. It was close to 90 to 95%.
And they had representation of all different types of color
Yeah,
schemes
like
and
obesity, wasting, stunt.
variety. And apart from that, color scheme also,
Yeah,
right? There are face types also. Chinese, they look different than maybe African guys, and white guys are different than Indians, and all that has been taken care of.
yeah, sir.
Okay. And you use, I think, what? Mobile net and shuffle net, something like that. These
Yes, sir.
two models you have used, right?
Yeah, sir. It is a lightweight with we can run on embedded
So
device
one
and
is better than the other. I think mobile net was better than the inaccuracy.
yes, yes, sir. Then shuffle
So,
it.
so mobile net is better, you said. So why it is better? What can be the reasons which contribute to the performance of some model?
I think, sir, different architecture style.
Apart from that,
But but
you have to investigate and find out why one model is better than the other. I mean, the statistics just say that one model is better than the other, but that may not be sufficient. You have to find out why it is better. What is there in that model which makes it better? Okay?
Okay, sir.
So you can investigate and include this in your paper in conclusion.
Yeah, yeah, sure, sir.
Okay? Thank you. Thank you very much.
Thank you, sir.
Yeah.
Thank you, Kushal, for your presentation. Now we'd like to move forward. I'd like to invite Mrunal Somnath Savle to present her paper on AI-based customized learning process for employee reskilling mode to achieve SDG 8, decent work and economic growth. You may start sharing your screen.
Yeah, thank you. Hope I am audible to you. I am
Yes, you're
sharing
audible.
my screen now. Okay. Just let me know when my screen is visible. Is it?
Yeah, it's visible.
Okay. So thank you so much, everyone, for giving me the opportunity to present my paper today. I am very happy with the subject that has been presented with related to the human health. My subject is mostly related to the employee well-being and sustainability. So normally we all know that when we enter in any organization, we get trained. So normally the training happens, common for all. My subject is common training in these today's fast-paced world is not enough, and in today's fast-paced world we need customized training for every employee. The first point. And second point is, when we are giving the traditional training, they are not important for the job roles, because traditional training is one for all and every job role is different, every responsibility is different. So my PhD topic is also similar, that which is AI based reskilling for sustainable development goal 8. And as a part of that, I'm presenting today's paper, which is learning process. So rationality of this study is also similar, that if we go ahead and give customized training to every employee, it would produce higher economic growth, which is 8.1 SDG. 8.2 is enhanced productivity, and 8.6 is youth employability. So this is all happening because if we are giving customized training to every employee. Normally what happens is, today there is a gap between traditional reskilling and today's employees need training which is very suitable for their job, which is suitable for their skill, and they think that the traditional skilling reskilling is not enough, and they need something that is more suitable for their needs. So what we do is, we do advanced AI based reskilling, which first go into employees background, employee strength. They give some questionnaire to the employees, and based on that we make reskilling which is important for specific their job role. Out of all this thing, we are able to achieve SDG 8, that is decent work and economical growth, because this will decrease the work related stress, this will cause the better resource alignment, this will reduce the resource wastage. This is the future of the study. Objective is very specific, that we need to create AI based personalized learning systems. For that we need to create a conceptual model, and we need to prove that this helps maintaining the decent work and economical growth. Scope is very limited. We do not go ahead with a lot of skills. We only relate what is relevant for this study. It depends upon primary data, though the secondary data will also be a very useful thing, but for this study I have used only primary data for this study. And the AI technique that I have used is predictive analytics, language processing, and machine learning. Of course, there are a lot of AI techniques which would be useful for this study, but I have restricted to this because these are mostly used as per whatever organization that I have observed for my studies, for my paper, and for this also. I understood that these are the skills that has been mostly used. These are the literature review. Based on the existing literature review, I also have taken some theories into the consideration. So, Singh et al., Madhumita, Sharma, Khan, Davis, and Anector, these are the people who have already written on this. But apart from that, I have also taken three theories. First is acceptance of technology theory, that whenever a person accepts any type of technology or AI, their work becomes easy. Constructive learning theory, that AI helps learning very constructive. And human based AI theory, that AI, if they are adopted to the skill space or learning of an individual, it will increase their ease and it will increase their work patterns. Research methodology, I have taken the entire study with 500 people. This is purposive sampling. I have taken the entire thing with five. A questionnaire has 5 sections. First is what was their personal information, what are the traditional reskilling process that they observe, what are the AI based learning process they have, and then apart from that, what was the impact on SDG. This is the conceptual model which would be the future of this study, which I would like to involve. That when they were on traditional reskilling, what was their work pattern? When AI is integrated, what was their work pattern? How the personalized reskilling is working for them, and how they achieve the SDG through it. So I want to have all these 4 steps integrated to have a conceptual model as a future of this study. And this is my results. So what I observe is sector wise, IT sector is mostly adoptable for the AI techniques, which is followed by marketing, and HR, manufacturing, operation are still to get there. Comparison, I thought when we have traditional reskilling, 40% of ease of understanding, but when we go for AI base, it increased to 60. So every pattern of a person's understanding increase at least by 20 to 25% when we involve AI techniques in it, and it helped them to improve. Again, understanding level also increase. Initial level employees, 10% improvement in the understanding, mid level 46, and expert level, which are already very good in their job, 87% understanding has improved just because they have AI based customized learning. And then the most important thing, how it improved in SDG. Skill improvement happened 65%, job promotion 39%, motivation level 80%, which was also my surprise thing. Perception is 70%, and economical growth is 72% because it saves time, it saves resources. So conclusion is, based on the survey, we know that individuals from different industry understand that if training is based on skill, education, and capability, they'll be happy, and we would be able to achieve the SDG 8. Suggestion is this can be this study is only applied to 500 participants. Of course, we want to apply it to more people and study more people so that decent work and economical growth can be achieved. Thank you. Yeah.
So, do you have any questions for her?
Yes. Yeah, so this is a survey, right?
Yes.
Okay, how many users or persons were involved?
So for this study, I have involved 500 people from the organization which have already integrated AI into their HR skilling system.
Okay. How they were selected?
So it was purposive sampling. I had friends, and from the LinkedIn, I first asked them that whether you are using it, and from there, I have
We call
selected
it convenient sampling. It's not a
convenient.
random sampling, it's a
Yeah,
convenient
purposive
sampling.
sampling. I say yes, sir.
What you said?
Purposive. On purpose, I have
On
selected.
purpose, but is it convenient sampling?
Yes. Okay, I'll correct it.
Normally, you have people you know or who are connected to you.
Yes,
Those
sir.
were sampled.
Yeah.
Okay. You use TAM, I heard somewhere. TAM.
Yes, sir.
Technology acceptance model somewhere.
Yes.
What what do you know about TAM?
Sir, as per my understanding, people, if they are willing to accept the technology and they are ready to involve the technology in the day-to-day work, the motivation level will increase. They were happy about the technology and their
Do you know
impact.
how TAM works?
Not specifically, I have only studied for my entire
But
my.
studied with what are the components of TAM?
No, sir.
You studied, so you have to know.
I understand. I will
You
go into
say
deep.
all those models are there.
Yes.
TAM works on user acceptance and user satisfaction
Yes, sir.
and user feedback.
Yes.
You have to find out. So
I would
whatever
say.
you are doing in survey, so you are finding what were the findings of your survey?
So as I showed in the entire thing, like when we go ahead with the traditional reskilling, the motivation level is 40%. And if we go for the AI-based reskilling, the motivation level also increases. Same goes for the ease of work, same goes for economical development. So
Anything negative you found out?
yes, there were negative findings, but which I have included, like some people, especially the employees who are very well versed with the old technology, they find this new challenge or new AI technique overwhelming, And for that, reskilling and learning processes are required. So they find it overwhelming, and they find it needs a little time for them to adjust and integrate.
Okay. So thank you very much.
Thank you, sir. I'll definitely involve the things that you have done.
Thank you so much, Mrinal, for the presentation. Moving forward, I'd like to invite our next presentator, Shubham Singh, to present his paper on AI-powered API gateway for threat detection and management. You may start your presentation.
Just wait for a minute.
Yes.
Yeah. Good afternoon, everyone. Myself, Shubham Singh. Today, I, along with my teammates, are going to present our research work on titled AI-powered API Gateway for Threat Detection and Management. APIs have become the backbone of the today's digital infrastructure. Whenever two applications need to communicate or they wanted to expose their services to the client, they do it with the help of APIs because APIs allow to share data without exposing the underlying infrastructure. And because of this reason, it has been used in almost all the modern applications, be it in the banking sector, healthcare, e-commerce. So as the usage of APIs have increased by 400% in the last 2 years, the attacks on them have also been increased. And the existing systems which we have, like firewalls, IDS, they are good for detecting known type of attacks, but when it comes to adversarial attacks, unknown attacks, behavioral analysis, they lack. And our goal here is to build a lightweight real-time AI-powered system which can be used in time-sensitive applications. So these are the limitations of the existing system. They only detect known type of attack patterns like SQL injection, command injections, but attackers are smart enough to bypass them. And also, the existing solution lacks behavioral and intent-based analysis. That is, they treat each request individually and it does not take the past behavior of the user into account while deciding whether a request is malicious or genuine. Third, all the applications which are using ML model, they have no prevention against the model itself. It means the model can easily be reverse engineered and it can easily bypass the model restrictions. Fourth, lack of workflow validation to prevent API logic abuse. Here, the proper sequencing in an application context is not being used by the applications to avoid jumping of the attacker from one step to other step. Let's say in the e-commerce application, if someone has not done a payment of a product, they can directly jump somehow to the order page. Now, the fifth one is the higher dependency on expensive enterprise security solutions. The existing system are also expensive, which is difficult for the startups for having a subscription. Yes. So here comes our system. Our system is a multi-layered AI-powered gateway for threat detection and management that combines pattern detection, behavioral analysis, machine learning, and adaptive decision making to prevent against both known and unknown form of attack. And our application sits between the client and the backend. Every request that is coming from the client first go to our gateway. Then based on the analysis, we decide whether to pass that request or block that particular IP. Although there are various novelties in our system, these are the three key novelties. First is semantic drift. That is, we are also taking the past behavior of the user into account while deciding the authenticity of the current request. Second, the ML model we are using, we are also providing security against that so that someone cannot reverse engineer it fully and know about all the threshold and internal level details. And third is gradient mimicry. Let's suppose model probing has happened somehow, then also the attacker cannot bypass our system restrictions. Yes. So now deep dive into our system architecture. The first layer is the client layer. Clients can use any of the medium, web client, mobile apps, third-party APIs to interact with our gateway. Then we will reroute the request for load balancing. We will check for basic authentication that whether the particular user is the right person to access that. Then the third layer will be the request preprocessing, where we will make our API ready to extract the features with the help of extracting the metadata out of it, header parsing, JSON normalization. And in the layer 4, we will extract the features from the APIs. We are extracting 25 features like path length, body length, payload entry, HTTP method type, response status code, then inter-arrival rate, all these things we are extracting, and then we are making a vector of the features, which is going to be used in the next layer. Then we have layer 5. It is a parallel layer which will attack different types of attacks. First, it is rule-based attacks, that is pattern detections for SQL injection, cross-site scripting, path traversal. We are also using two ML algorithms over here. First is isolation forest for anomaly detection, which will detect unknown form of attacks. And we are having light GBM for classification, which will be detecting known type of attack. Along with that, we are also covering behavioral-based analysis, in which API workflow attack comes along with the semantic drift, then EDOS, that is economic denial of sustainability, where someone is constantly trying to increase the cost of our cloud applications. And third is we are using IP reputation scoring system, in which we will be maintaining history for 25 or 24 hours of a particular IP, and also Slodius attack. Now, all these things will be combined in the unified thread scoring layer, where we will be calculating the combined score. And in the layer 7, we will be taking the decision whether to allow that request to the backend, throttle, or block that request. Now, layer 8 is our protected backend layer with which our users will interact. Yeah. So here is the dataset we have used. First is CI/CD dataset, which has been used for known types of attacks. Then we have bot IoT for the attacks which are being done by bots like EDOS, DDoS. And then we have also used third type, which is synthetic dataset we have created on our own for making it close to the real world scenario. And the dataset split is 70% we have used for training, 15% for validation, and 15% for testing. Next slide. Yeah, implementation will be explained, Mike. Yeah.
So this is the implementation. This is the React dashboard which we have made. Firstly, when the user will come, he'll create an API key from here, and when the API key is generated, there is a unique key which he or she have to pass to the backend layer while preparing the backend. Then he'll create a service. While creating the service, he can also identify like how much the request you want to give and what is the rate limiting you have to set for his particular system. And then when it is created, then service is created, API is created. Now when he'll design the system, then he'll pass on both this service and the API layer to the gateway, and then it will be connected to a system. So here all the logs will be detected, like on what time the API key, then from what IP, response time, whether it was critical threat or it was a clean request. If it's the attack, then attack will be detected, and then IP will be blocked. Then the user have to go to the on the IP reputation, and then he or she have to unblock the IP. So like from that IP, now the request will be sent further. If the IP is blocked, then we can't send the request from that IP, and that IP is permanently blocked.
Yes, these are our results. We have a 100% detection rate with a 3% false positive and 0.98 F1 score. And we have also achieved a latency of 20 milliseconds, which is very important considering our system is lightweight and used in the time sensitive domains. And these are the other applications which are the existing ones. So we have beat them with a good benchmark score.
Sorry to
And these all,
interrupt, but I'd request you to conclude your presentation now.
sure, these all are the references that we have used. And now, thank you for giving us the opportunity, and we are open for any questions.
So you have any
Okay.
questions for them?
Yes. You are extracting some 25 features, you said.
Yes.
So these 25 features, I think, have some behavioral or some temporal,
Yes, sir. They are
features,
temporal, behavioral, and protocol based.
protocol based. What are these protocol based features?
Sir, these are the HTTP method type, response status code, then payload entropy, URI length, parameter count,
Okay.
header to payload.
Okay. Those are related to protocols.
Yes, sir.
And what about this behavioral features?
Sir, in behavioral feature, we are taking the previous history of the user into account, that the previous requests that he has made, whether they are
Hmm.
malicious or genuine. Yes.
And how do you make the decision
So,
whether to
sir, the decision
accept
comes.
the request or not?
Yeah. So, sir, basically it passes from the layer 5 where we check the request against all the different types of attacks which is detected parallelly. And if
Mhm.
there is any form of attack which is being in majority, then we flag that request and will not allow it to proceed it to the backend. And we will also block the IP so that no further request can come from that particular IP in 24 hours.
And what is your affiliation? From which university you are?
Mumbai University, DJ Sangri College.
Sangvi College, Mumbai. Okay, okay. Okay, thank you.
Welcome.
Thank you so much, Shubham, for your presentation.
Thank you.
Now, I'd like to move forward. I now ask Yash Gaikwad to present his paper on an AI-powered framework for real-time sign language translation in video calls. You may start with your presentation.
Hello, ma'am. Am I audible?
Yes, you're audible.
Be sharing. So, is my screen visible?
Yes, your screen is visible.
Just a moment. Good afternoon, everyone. My name is Yash Gaikwad, and today I'm going to present my research paper titled "An AI-powered framework for real-time sign language translation in video calls." So this work was basically carried out under the guidance of my faculty and in collaboration with my teammates. This research focuses on using deep learning, computer vision, and AI to enable real-time communication between deaf or mute individuals and people who do not understand sign language. Uh, so, communication is like the most basic human need. And for deaf and mute individuals, communicating with people who do not like understand sign language is basically a major challenge. Although sign language is a complete language, very few people actually put in the effort to learn it or understand it. And because of this communication gap, many people face difficulties in education, employment, healthcare, and daily life. So, to solve this problem, we have developed an AI power system that recognizes sign language in real time and converts it into text and speech during video calls. Uh, this is the related work that we have referred to the papers to understand how the system basically works. Deep learning for uh, recognizing hand gestures, CNN for image classification, LSTM models for recognizing gesture sequences, uh, media pipe for hand landmark detection, sensor-based systems using gloves or flex sensors, uh, recognition systems for ASL, ISL, Bangla, and Chinese sign language. Although these approaches achieved good recognition accuracies, most of them had limitations. Many systems required expensive hardware like sensor gloves. Some only recognize static images instead of continuous gestures. Others were not integrated with real-time communication platforms like video calls. So, because of these limitations, we decided to build a more practical solution. So the novelty of our project is that it first performs a like real-time sign to text conversion and then sign to speech translation during video calls. It also supports two-way communication, allowing deaf users and hearing users to communicate naturally. It is also designed as a cross-platform solution, so it can work on web and a mobile device as well. Uh, these are the methodologies that we have implemented in our project. KNN basically compares the detected gestures with gestures that are already stored in the training sample, and then it is classified. CNN extracts special features like hand shape, fingers, positions, gesture, etc. LSTM is used to like understand sequence of gestures over time. LSTM basically captures temporal information and improves recognition of dynamic signs. This is the architecture diagram. The process starts when the user performs sign language in front of the webcam or mobile camera. The camera continuously captures video frames. Next, media pipe detects the hand landmarks and extracts important features such as finger positions and hand movements. Uh, the extracted features are sent to the CNN and LSTM models for gesture recognition. After prediction, the recognized sign is then converted into text. And finally, the text to speech module converts the text into voice. The complete pipeline enables smooth real-time communication during video calls. Results and discussions. So our system has basically achieved approximately 85% recognition accuracies. Uh, so the things that we have observed so far are that static hand gestures achieved higher accuracy than dynamic gestures. So because some gestures had like similar hand shapes, they were sometimes misclassified, and better lighting conditions significantly improved recognition performance. And according to our testing, average inference latency is around 38 milliseconds per frame, and the system processes approximately 26 frames per second. In the discussion and results. So although our system performs well, there are some opportunities for improvement. In the future, we actually plan to add a few things into it as well, like multiple sign languages, including Indian Sign Language, and increase the vocabulary by recognizing complete words and sentences instead of just alphabets. Improve the recognition accuracy using more advanced deep learning models, add regional language support, and improve performance under different lighting conditions and camera angles. This is the model accuracy over epoch. As you can see, it is improving with each epoch. For the conclusion, our research basically presents an AI-powered framework that bridges the communication gap between deaf or mute individuals and people that are not able to communicate using a sign language. Uh, by combining computer vision, CNN, LSTM, and text-to-speech technology. They are the Thank you. Thank you so much. I'd like to take some any questions if you have.
Okay. Yes, thank you very much for your presentation. I hope you are able to hear me. Yes, are you able to hear me?
Hello,
Hello.
hello, sir.
Are audible.
Are
Yes,
you
sir.
able
Yes,
to
sir.
hear me?
Yes, sir. Yes, sir.
Ah. Okay, thank you for your presentation. You mentioned about
Yes,
ISL,
sir.
Indian Sign Language. You also mentioned about Bangla and Chinese sign
Yeah.
language.
Yes, sir.
Do you know the differences between these three? How different they are?
Sir, the alphabets would be different. Like in American Sign Language, we have a sign for every alphabet, like A, B, C, D,
Hmm.
and just like that for Indian and Bangla, the for each alphabet we would have like a different sign language.
Huh.
So,
What about
gesture.
what about emotions?
Sir, right now the system doesn't basically recognize emotions, but that is like one of the future scope that
No,
we
no. What
plan
I'm
to add
saying
into
is,
our
in
project.
sign languages, is there
Yeah.
anything which detects emotion?
Emotions are not so far. Like in the American Sign Language, it basically only
I
has a
think
gesture for each
they
alphabet.
recognize emotions.
Uh,
Sign languages, definitely. If somebody is happy, somebody is sad, definitely there are gestures which tells you. Emotions can be detected. Anyway, second issue is this is a real-time translation, right?
yes, sir.
So what is the latency? How much time it takes?
Sir, the latency is basically 248 milliseconds from complete like sign to speech, but sometimes it may delay a bit due to like lighting conditions and stuff.
Hmm. Because it's a image processing.
Yes,
Hmm. Lighting condition has to be proper.
yes, sir.
Okay, thank you. Thank you very much.
No, thank you, sir.
Thank you so much for your presentation, Yash.
How many presentations more? Any idea?
So I'll just check. Just a minute.
Hello, ma'am.
Yes?
App ID 687 was 617. I mine was disconnected during summarization of the result. 687
Yes, sir. We were notified about you. We'll be taking your presentation in the very end.
variant. Okay, ma'am.
Yes, sir.
Okay, ma'am. Thank you, ma'am.
So we still have six presentations left.
Okay. Too long session. Oh
Yes.
my God. Already five done. Okay, go ahead.
Yes. Then now I'd like to invite Sanjay to present his paper on comprehensive analysis of OTP fraud and UPI scams in India. You may start your presentation.
Just 1 minute, ma'am.
Yes.
We are facing a issue. Ma'am, is the screen visible?
Yes, your screen is visible.
Okay. So, good afternoon to all. Before I begin my presentation, I would like to briefly explain why we selected this topic. Over the last few years, India has witnessed an enormous growth in digital payments, mainly because of the UPI. Today, almost everyone from students and working professionals to small shopkeepers and even street vendors uses UPI for everyday transactions because it is fast, convenient, and available 24 by 7. However, along with this rapid digital transformation, cyber fraud has also increased significantly. Every day we hear about people losing money through OTP scams, phishing links, fake QR codes, SIM swap attacks, and impersonation scams. While many existing studies focus mainly on technical detection methods, we felt that the actual problem is broader. Fraudsters rarely hack the UPI infrastructure. They manipulate people using fear, urgency, trust, and confusion. So, our researchers aims to understand how these frauds occur, why users become victim, and how an integrated analytical framework can improve fraud detection and prevention. With this brief introduction, let me begin with the presentation. The title of our research paper is Comprehensive Analysis of OTP Fraud and UPI Scams in India, a behavioral and workflow based framework for detecting and preventing digital payment fraud. This research was carried out to analyze different types of UPI frauds occurring in India, understanding their behavioral and technical aspects, and propose a comprehensive framework that can help financial institutions researchers and policymakers better analyze and prevent such frauds. I will now present the major findings of our work. I'm just So moving on to the agenda, this presentation is divided into 10 major sections. First, I will briefly introduce UPI and explain the problem statement. Then I will discuss the objectives of our research, the different types of fraud analyzed, the research gap, our methodology, the fraud cycle, the proposed analytical framework, evaluation results, mitigation strategies, future work, and finally conclude the presentation. Moving on to the introduction. Before discussing fraud, it is important to understand the UPI. UPI, which was introduced by the NPCA in 2016, allows users to transfer money instantly between bank accounts using a smartphone without entering bank account numbers of IFSC code every time. UPI became extremely popular because it supports real-time bank-to-bank transfers, QR code payments, interoperability between different banks, and is available throughout the day. Due to these advantages, billions of transactions are processed every month. However, the same convenience has also created opportunities for the criminals. Instead of attacking the banking infrastructure directly, fraudsters manipulate users into voluntarily approving transactions or sharing confidential information. Moving on to next slide is the problem statement. The problem statement, the main problem identified in this study is the rapid increase in OTP and UPI fraud. As digital payment adoption has increased across India, fraud cases have also increased significantly. One important observation from our study is that UPI infrastructure itself generally secure. Instead, fraudsters exploit human psychology. They create urgency by claiming that the victim's bank account will be blocked, build trust by pretending to be bank officials, or confuse users into scanning fake QR codes or approval collecting requests. Therefore, this research focuses not only on technical security but also understanding human behavior because preventing fraud requires both perspectives. So these are the research objectives. The research has five main objectives. The first objective is to analyze real world OTP and UPI frauds. The second is to identify common fraud patterns and classify them into different categories. The third is to study behavioral factors such as fear, urgency, trust, and confusion that influence victims during fraud. The fourth is to develop an integrated analytical framework that combines technical analysis, behavioral analysis, and system analysis. Finally, the research proposes mitigation strategies that can help users, financial institutions, and even policymakers reduce digital payment fraud. So these are the major fraud types. Based on our analysis of real world real world fraud cases, we identified five major categories of fraud. OTP fraud is the most common category, accounting for 42.3% of all cases. In this type, victims are tricked into sharing their one-time password. Phishing account for 23.7% of cases where attackers create fake banking websites, messages, or emails to steal confidential information. And then comes fake QR code scam, where victim believes they are receiving money, but actually authorize payment. And comes the impersonation, where fraudsters pretend to be bank officials, customer care executives, or uh, government authorities. And finally, the SIM's mobile number and intercept OTPs. Existing research mainly focuses on three fraud patterns change. The second uses machine learning algorithms such as random forest, support vector machines, and neural networks. The third is a graph-based analysis which studies relationship between multiple fraudulent accounts but requires significant computational resources. The main research gap is that these approaches usually analyze technical, behavioral, and policy aspects separately. Our research integrates all three perspectives into one analytical framework specifically. Moving on to the next slide is about methodology. Our research methodology consists of 6 sequential stages. First, we collected fraud cases from banking ombudsman project reports, cybercrime complaints, and banking advisories. Then collected data was then pre-processed through normalization, categorization, anonymization, and sequencing. Next, fraud cases were classified into 5 major categories as we had seen previously. Behavioral analysis was then performed to identify psychological triggers such as urgency, fear, trust, and confusion. Based on these findings, we developed the proposed analytical framework. Finally, the framework was validated using cross verification, expert review, and case simulation.
I'm sorry to interrupt, but I'd now request you to conclude your presentation.
Yeah, just a minute. And this is the fraud life cycle. Here, the attacker the attacker contacts the victim first, and then attacker builds the trust, and then the trust is established. The attacker requests an OTP and sends fear, and then the victim unknowingly authorizes the transaction. Finally, money is transferred from victim's account. Here comes a slide where proposed analytical framework of 3-layer architecture. The first layer is data acquisition, second is processing and intelligence, third is decision and support. And this is the evaluation result. The proposed framework was evaluated using this much real world fraud cases between 2022 and 23. It received an overall accuracy of 92.4%. And then these results indicate that integrating behavioral indicators with technical analysis improves fraud detection compared with traditional approaches. Key findings. Our study produced several important findings. The first finding is social engineering responsible for most successful UPI. The second is the human behavior. Third, combining behavior indicators. We also observed that phishing and OTP theft are frequently used in coordinate attacks. And this is the mitigation strategy. The first pillar focuses on user awareness. The second includes technical measures. Third emphasizes institutional measures. And finally, the policy support. This is the future work. Although the proposed framework provides a comprehensive analytical approach, several improvements can be explored in future research. These includes AI-based real-time fraud detection, behavioral biometrics for continuous authentication, blockchain-based secure fraud reporting, etc. These advancements can further strengthen digital payment security in the future. And finally, the conclusion. To conclude, UPI has transformed digital payments in India by making transactions faster, easier, and more accessible. Our research demonstrates that fraud prevention requires not only technical security but also an understanding of human behavior. We believe this framework can support banks, researchers, and policymakers in improving digital payment security. Thank you for your attention. So, I conclude with this.
So, do you have any questions for him?
Actually, you spend lot of time on introduction and general knowledge, 75% of the time. And you presented hardly anything which is expected. So my question is, how time mismanagement was there? So actually, you should present the thing that is not presented well. You presented all other things which were known and well known. So how do you find a fraud? What technique is used? That yes, answer this question. How do you identify a fraud? And what
So
kind of
there are certain patterns.
how do you identify it? Obviously, there are patterns. So how do you identify a pattern?
So if you don't mind, my co-author wants to answer this question. Can you allow
Okay,
this?
anybody can answer, no problem.
Thank you.
So, like sometimes there might be unreasonable questions they might ask, right? Like they can ask for to scan the QR code for them in request
Hmm.
of giving us money.
Hmm.
Those type of patterns we can use, sir. And sometimes there might be request of there might be complaints like which were recorded, like after sending the required payments, they might ask us to, like, they might have complained, like they have received this much amount from us, but we didn't wanted to give it, like they might have used those complaints, right? It might be from individual or from the group.
Hmm. Okay. Actually, the question was technical. So basically, this paper has very less technology, lot of general knowledge, and other things. That is my observation. Okay.
Okay.
Thank you very much.
Thank you.
Thank you so much for your presentation. Now we'll move forward with our next presentator. I'd like to invite Omkar Darve to present his paper on federated learning for decentralized computer vision training at the edge devices. You may start your presentation.
Am I audible?
Yes, you're audible.
Okay, let me just share my screen. Okay, is the screen visible?
Yeah, your screen is visible.
Okay, I'll start then. Good afternoon, everyone. I'm Omkar along with my co-authors Mihir, Hitanshu, Pranav, and our mentor, Professor Abhijit Joshi. I'll be presenting a paper, Federated Learning for Decentralized Computer Vision Training at Edge Devices, or as we call it, FedVision. Next. This is our agenda for the presentation. I'll start with the problem, why existing approaches fall short, walk through our system architecture and the core algorithm, and share a result across four dataset, and close with a few key takeaway and our future work. Coming to the problem background, training computer vision models certainly means shipping massive image dataset to the cloud. That's expensive. You're paying for GPU hours and bandwidth. It's slow since everything funnels through one server. Our core idea with Thread Vision is simple. Instead of moving the data to compute, we move the compute to the data. We take a shared data set, split it into data shards, and hand the shard to a trusted pool of edge devices. These includes laptops, small servers, whatever idle hardware you have sitting around. So training happens in parallel, close to where the hardware already is. This gets us three things. The data stays inside authenticated set of devices. We harvest hardware that we already own instead of spinning up new cloud servers. And because we are not spinning up new data centers, there's a ecological value to this too. Going to our related work and the research gaps that we saw, was that this isn't the first system to think about edge-based federated learning. Frameworks like Axio framework from ML System and FedCS both look at matching job to devices and scheduling clients based on their capability. But we noticed a pattern in literature. Most of the work is validated in simulations. Papers assume a bit of perfect uptime. There is uniform hardware between them. There is ideal network links, but in real edge development, there are issues such as the device can drop out of the training loop. There are battery throttle performance, and the biggest issue that we saw was NAT gateways. There is also what we call as an integration gap. A lot of these systems don't actually bring heavy ML frameworks like PyTorch with lightweight networking layers with Go in real running implementation. That's the gap FedVision is built to close. Coming to our approach for our paper is that FedVision is a coordinated peer system. Go handles the orchestration and networking. PyTorch handles the actual model training. Four things define our approach best. We see the first is hardware-aware distribution. We score every system and stream it data shard size to match its capability. Second is we have lightweight edge clients, so the edge is not overwhelmed. The third is on device training. Each peer fine tunes a MobileNet V2 backbone locally and serializes the weight as it updates. Fourth is multi-round convergence. We loop updated global model back to each device across several rounds. This reduces variance in aggregation as well as pushes accuracy up over time. Next, we go to the system architecture. Yeah, here's how it all fits together. A central node is the main controller. It drives the whole life cycle. It partitions the dataset, streams shards out, collect file weights back in the form of PT files, and it also broadcasts new global weight each round. Alongside it, a session manager issues secure ID to peers and two Flask microservices that handle the scoring algorithm and the aggregation math. On each edge device, uh, we run a benchmark module, which basically gives us the amount of data that we are going to send to it. A Go-based edge client manages the WebRT connection, and a Python service is actually used to train the model. And then the whole model is sent back to the aggregator, which creates a global model using all this data, and then loops continues for a predetermined number of rounds. Coming to two innovations in our approach is the hardware-aware scoring. This is basically what would be defined as the heart of the system, how we decide how much data each device gets. We compute a priority score for every peer using throughput in images per second, composite health scoring for CPU, RAM, GPU, round trip latency for the coordinator, the throttling we basically run a very small CNN model and just see the amount of time it takes for it for one pass. And there's a battery penalty which basically penalizes you if you're on battery versus on actual like power. Uh, Now we multiply those, we get a score, and this score is then shared and then normalized against all the other scores that we have gotten, and that's the actual fraction of data set that each device will get. Now coming to our aggregation process, our training finishes on all devices for that round. We merge the results. Each peer sends back its updated weight, and we combine them using weighted fed average formula. So a device that got a bigger shard will have a higher influence over the merge model. We repeat this process over a number of rounds in the life cycle. And this basically drives up our accuracy by reducing variance between different models. Coming to the datasets that were used, we tested this approach across four different computer vision tasks, deliberately picking different types of tasks. One of them was a standard mentioned data, which where we classify numbers. Then going to blood cells, which is a cell microbiology dataset, and then there's breast, which is a brain MRI scans, and butterfly, which is a standard classification of 75 classes. The point of this spread was to stress test the system on domains diversity from simple digit recognition all the way to biomedical imaging, and to see how our approach holds as we scale from one device to 12 devices. This is the result of this whole process. Uh, so as you can see, there are two graphs. And what our takeaway from our whole research was that training time reduces drastically, uh, while also there is an accuracy drop off because we lose some information when we are averaging. But this approach still holds for, like, for example, MinSet, we have around 97 accuracy that drops down to 94, and even our hardest data set, the accuracy drops from 84% to 79. That's the expected trade-off with federated averaging. That's a small price to pay for the speed we get. And coming to the conclusion as well as the future work, uh, to basically sum up this our whole approach, Fed Vision uploads expensive computer vision training into a pool of trusted low power edge devices using hardware aware sharding to parallelize the work, cutting training time while keeping the data confined to an authenticated pool of devices. Looking ahead, we want to add dynamic workload rebalancing. So when a device basically drops off, we can give it data again and basically reintroduce it into the trusted pool, as well as support more vision models and adapt for lower power devices. And finally, our architecture is model agnostic. Nothing about the networking or aggregation layer changes if you swap the mobile net model for something else. And that's basically it. Thank you, and I'm happy to take any questions.
Okay, Omkar, thank you very much.
Okay.
So your work is with edge devices, right?
Yes. So basically, what we have, like we basically have a bunch of computers in our labs. We are basically using them for edge devices right now.
So edge devices. Normally, all types of edge devices works. They are compared with cloud computing services.
Yes, sir.
So how do you compare your work with edge to cloud computing?
Sir, through cloud, what we was wanted to basically introduce was uh, like having hardware that you're not using and using it to basically train new models. When you come to cloud, you basically obviously get better performance, but then it leaves a trusted pool of devices that you are basically sharing your data with the cloud that not might be permissible in all tasks, as well as there is a computation it's also expensive. So this is basically we are using recreational devices that we have already to use for our ML training.
Okay. You are calculating some scores in between, I just saw, right?
Yes, sir. We are.
So,
Oh,
how it helps in federated learning, calculating scores?
so what we observed was, networking is not really an issue for us, but what was an issue was basically if there are multiple edge devices and there is they are not they don't have uniform hardware. Some might have better RAM, some might have better processing capability than other. So what the formula basically does is basically give a device which has higher capability a higher amount of data so that it can pass through it quickly, as well as we also give it more weightage when we are making a global model, so that more the device that has more data has more influence over how the model basically comes together in the final picture.
Okay. Okay, thank you. Thank you very much. Sure.
Okay, thank you, sir.
Thank you so much, Omkar. Now, I would like to call upon our next presentator, Goli Lakshya Reddy, to present her paper on Foresight, Hybrid Machine Learning, Deep Learning Framework for Predictive Maintenance and RUL Estimation. You may start your presentation.
Has it started? Because I can't hear anything.
No, I don't think so, sir. Miss Goli, we can see your screen, but you're not audible.
I'm sorry. I've started the presentation, but I'm sorry. I'll continue on.
It's fine,
Yes.
you can start over again.
Yeah. So, good afternoon, everyone. I am Lakshya Reddy from Departments of CSC from Geetanjali College of Engineering and Technology. So, today I'm presenting our paper titled as Foresight, which is a hybrid machine learning and deep learning approach for predictive maintenance and remaining useful life estimation. Nowadays, if we take industries, these are moving towards industry 4.0, where the machines are connected through IoT and are continuously generating sensor data. Now, if we take these industries, one major challenges they face is an unexpected machine failure. Now, if we take the traditional maintenance approaches, such as reactive and preventive maintenance, these are not efficient. Coming to the reactive maintenance, these repair the machines only after a failure, and this can cause downtime. And coming to the preventive maintenance approach, it replaces the components at a fixed intervals, it even if they are still in a good condition. Now these both methods, they increase the maintenance costs and also reduce the productivity. Now to solve this problem, we developed Foresight, a hybrid predictive maintenance system that uh, predicts machine failures before they occur, and also it estimates the remaining useful life of a machine. Now this helps industries performance maintenances only when they are necessary, and they reduce the downtime and also improves the equipment's reliability. Coming to the problem statement, if we take the existing maintenance systems, they only focus on one task, and also some systems, they perform only a failure detection, fault detection, and other they only estimate the remaining useful life of the system. And many existing approaches, they also rely on a single machine learning algorithm, which this limits to a prediction accuracy. Now, in addition, most systems, they do not provide comprehensive evaluation, and they do not compare different algorithms with each other. Now, therefore, there is a need for a system that can combine both fault detection or fault classification along with the RLU prediction in a single framework. Coming to the objectives of our project, the main objectives are, first we detect different types of machine failures, and then we predict the remaining useful life of the machine, so that this can reduce the unexpected downtime and maintain the costs. And this will help industries to schedule maintenances in advance and save costs. And we can also see that many industries, due to a sudden failure, stopping the production line for a few hours can cost millions. Now, coming to the method that we, or the approach that we used, our framework combines both machine learning and deep learning models. So, we used sensor data of different attributes such as air temperature, process temperature, rotational speed, etc. Now, first we pre-process the data by cleaning missing values and scaling the features. And next, we train different machine learning models first, which is we use SVM, which is the support vector vision, and a decision tree, random forest, and KNN. And then we also used deep learning models, which is such as CNN, convolution neural network. We use the CNNs because it automatically learns the complex patterns from the sensor data. And after all these processes, we have taken the graphs and compared both machine learning and deep learning models and taken the accuracy. And at the end, we used a regression model to estimate the remaining useful life of the machine. Coming to the results, our hybrid framework produced very good results, such as the system achieved about 97.1% of accuracy in fault detection. And when we compared all the ML models, this is the different types of failures that we are trying to identify. And this is the comparison graph of different models that we used. And here we can see that the CNN, deep learning CNN model, have given the most accurate values. Now coming to the RLU prediction, it has predicted an AME of 2.5, which is the mean absolute error, and RMSE of 3.01. These values indicate that the prediction or predicted errors are very low and the prediction is very accurate. So these, now coming to the advantages of our framework, is that it predicts the fault detection early, and also it reduces the maintenance costs, and it gives a less machine downtime and improves the productivity. Coming to the future aspect, future scope, we would like to take this further or enhance by integrating this real-time sensor data from the industrial IoT devices into this, so that we can continuously monitor the health of the machine, and try to deploy deploy it in cloud platforms, and try with edge computing. And to conclude this, our hybrid framework combines machine learning and deep learning for accurate machine failure prediction and remaining useful life of estimation. This helps industries perform maintenances at the right time, improves reliability, reduces costs, and also increases the efficiency. And even in the future, we are planning to improve the model by handling noisy sensor data by using lightweight deep learning models and support real-time industrial applications. Thank you for your time. I'll be happy to answer any questions.
So, do you have any questions for her?
Yeah. So it is only about predictive maintenance. It's not about maintenance, right?
No, sir. Actually, we are trying to predict whether there is a failure in a machine or not, so that the maintenance cost will be reduced. The If we stop a production line for few hours, it can take millions of dollars for the companies or the industries. So even if we take the already existing solutions or approaches, they either do maintenance after a failure occurs or in a fixed schedule time. So in the meantime, if any failure occurs, they might not identify it properly. So that is why we are trying to do so.
Okay. So if let's say you detect a possible failure, what happens?
So that we can intimate them with a red alarm or something, sir. And also, it's not only about we are predicting earlier. We are trying to say which type of failure it is. Sometimes it might be
What are the
power.
different types of issues or failures or errors you are talking about?
Sir, we are trying to like different types of errors that we are trying to show is overstrain failure or heat failure or power failure, tool-way failure, these kind of stuff.
Okay, thank you.
Yes, sir. Thank you, sir.
Thank you so much for your
Pranjal,
presentation.
Pranjal madam, I have messaged you. Have you seen my message?
No, sir, I'll see it now. I would now like to move forward
No,
with
no, just
our
look at the message and then.
Okay, sir. Yes, sir. Uh, just a
I have messaged you.
Yes, sir, just a minute. So, would it be possible for you to attend this one presentation?
Okay, fine.
Okay.
This will be
Thank
last
you
one.
so much, sir. Yes.
Sure. Okay.
Uh, I'd like to call upon Gokul to present his paper on mutation-centered hybrid metaheuristic and attention-based deep learning framework for Alzheimer's variant classification.
Hello, am I audible?
Yes, you're audible.
I'm not able to share the screen. Hello?
Yes, you're audible.
No, I'm not able to share the screen.
Oh, now.
Okay. Is this visible? Hello?
Go ahead. You can start.
Okay. Okay, sir. Okay. I'm Gokul S. I'm from Amritsar Dhyapedam. So today I will be presenting our work mutation-centered hybrid meta-heuristic and attention-based deep learning framework for Alzheimer's variant classification. My co-authors are Abhiram, Lakshmi, and Elizabeth, and we worked under the guidance of Pradhamol ma'am and Manjusha ma'am. So, Alzheimer's disease affects more than 15 million people worldwide, and among the hereditary forms of the disease, three genes play a major role, that is the APP, PSIN1, and PSIN2. The major challenge is that the disease-causing mutations occupy only a very small region along the long DNA sequence. When the entire DNA are muted by some either ignore the mutation-specific information or provide some predictions without explaining why a variant is pathogenic. So here are some. So first of all, the variant effect prediction tools are generally gene neutral or do not explicitly focus on the mutation-centered sequence contents. Then the deep learning models often achieve good accuracy but behave like a black box that makes the biological interpretation a bit difficult. Then the classic motive discovery methods can identify the recurring DNA patterns, but they are not like specifically designed around the disease-causing mutations. For our approach, the first we extract the fixed length mutation-centered window around every ClinVar variant. From ClinVar is the what where we took the genes. So the model focuses only on the biological relevant region. Next, we use a hybrid genetic algorithm and PSO to discover the highly descriptive sequence motifs. Then these motifs are optimized and then used together with a CNN enhanced attention mechanism so that the model learned the important local sequence patterns while assigning higher importance to mutation proximal positions. So this is our end-to-end pipeline. So here the DNA sequences are collected from the Alzheimer's associated genes. From these sequences, the mutation-centered windows are extracted around every known pathogenic variant. Then the sequences are then transformed to the numerical feature representations. These features are then passed on to the GA, that is the genetic algorithm, where the global expression occurs. Then the best motifs from there goes to the PSO module, where the local refinement takes place. Then the optimized motifs are fed to CNN attention mechanism, and finally, we use the Fisher exact test and TomTom tool to check the biological validations. So for the methodology, there are three main pipeline ideas: are the mutation window, then the hybrid GA PSO, then CNN network, CNN plus attention. So for the mutation-centered window, that is, instead of processing the entire DNA sequence, we extract a fixed length region surrounding each mutation. This reduces the noise while preserving the biologically important local context. Then the GA-PSO hybrid method, that is, genetic algorithm performs the global exploration to identify the promising motifs. Then the best motifs generated by the GA becomes the initial population for particle swarm optimization, which efficiently refines the candidates locally. Then the discovered motifs are statically validated using the Fisher exact test and the false discovery rate, where we used a Q value that is less than 0.05 for validation. Then for baseline and evaluation protocols, we separately evaluated the GA, the PSO, then GNN and MEME. And also for the evaluation protocol, we used a five-fold cross validation, then the variant level evaluation, then the TomTom tool for biological validation, and along with the matrices accuracy precision recall. So for results here, we are mainly showing the accuracy where we are able to achieve a 0.88%. But while comparing with others, it's just a slight higher variation. But we by combining the GA and PSO, we were able to outperform these methods. Then for the biological validation and explainability. So high prediction accuracy alone is not sufficient in the biological application. So we have validated the discount motives biologically. So the significant motives across the APP, PSEN1 and PSEN2 all satisfy the statistical significance threshold, that is a 0.05 Q value. Then both the explanation methods consistently indicated that the most influential sequence positions are located very close to the mutation. And so finally, we were able to develop a hybrid JPSO, then CNN attention framework to predict the mutation-centered area that causes Alzheimer's disease. And we were able to achieve a 88% accuracy. And for future work, we want to expand our data set, because from the ClinVar website, we were not able to get more genes related to Alzheimer's. And so we need also to pursue the experimental and functional validation of each enriched motif. And also we need to generalize the other neurodegenerative genes. There is external validation for cohort. So that's it, sir.
Okay. Thank you, Gokul,
Okay, thank you, sir.
for your presentation. So you said it's a genetical disease, like Alzheimer's is a genetical disease.
It's a neurodegenerative disease, sir.
But it genes play very important role in that, right?
Yes, sir.
Because there was somewhere like genetical variant, some prediction,
So that
something.
was genetical algorithm, GA, genetic algorithm.
There were three limitations or some missing points you were mentioning.
Yes, sir. That was first one. It's related to the data set. We collected the data set from from
Okay.
ClinVar.
Hmm.
So, and we were able to get around for each gene some 80, then 70, and 40. For PSN2, we got the least number of genes that were related to Alzheimer's. And it was also specific to a region. That is, these genes were mainly related to the Europeans. So it may get biased to that area. So that's
Okay.
why I used that limitation.
Okay. Thank you, Anaj. Thanks a lot.
Thank you, sir.
Yeah.
Thank you so much for your presentation. Now I'd like to invite the next presentator.
Okay.
Imad.
Thank you, Pranjal madam. I'm leaving. Okay. Thank you.
Yes, sir. Thank you.
Thanks.
I'd now like to invite Imad Khan to present his paper on semantic interference suppresses factual retrieval in GPT-2, evidence from a decoy needle in a haystack test.
I would like to share my screen.
You may present your screen.
Is my screen visible now? Hello. Hello.
Yes, you're audible.
Good afternoon, everyone. Today, we are going to present the research paper titled Suppressed Factual Retrieval in GPT-2, Evidence from a Decoy Needle in a Haystack Test. The author of this paper are Imad, Anshul, Chavi, and Anishka, Mahi, Chavi, and Dr. Ritu Sorian ma'am. We have prepared this research paper under the guidance of Dr. Ritu Sorian ma'am from Dronacharya Group of Institution, Greater Noida. Our work investigates how GPT-2 encounters and behaves when it encounters two similar looking facts in the same context, and how it behaves, and whether which input affect the aid's ability to retrieve the correct information from the given context. Now, large language model LLMs heavily rely on the attention mechanism to understand long context. However, the full attention mechanism becomes computationally expensive as the sequence length increases.
However, full to improve efficiency, several methods are already present in the market, such as long former, big word, limb former, performer, and splash attention, which have been already proposed. Although these methods improve speed, control, and very little control comparison or different attention strategies on the same model. Another important issue is the contradictory context. The previous studies show that the retrieval depends on the position of the information, and the irrelevant text can distract the model from answering the correct question, answering correct answer. But no study directly measured what happens when two conflicting answers are present in the same context window, and when what will happen when they appear with same together. They become this is the motivation for our research. Our research focuses on two major main questions. First, we wanted to know what happened at the sequence length and what sequence length the sliding window start to hallucinate and the model start failing to retrieve the real fact. Second problem is we wanted to know what happened when a fake answer called a decoy competes with the real answer present in the same context window. This is important because in the LLMs, the retrieval augmented generation system often combine information from the given context, and those sources may contain conflicting answer. In this case, the conflicting answer is the decoy one and the real answer is the real answer which is present in the context window. Understanding this behavior help improve the reliability of future AI systems. In the literature review, we have reviewed the previous work of two major areas. The first area is the attention mechanism, including the Lin former Big Bird, sliding plus global tokens, and performer flash attention and Mistral. The second area includes the CAMRAD and the long context retrieval include needle in a haystack test bench, which is a benchmark lost in the middle and studies on distraction in the language models. Most previous research compare different words while keeping the context same and the mechanism same. But in contrast, our work keep the GPT-2 model fixed and changes only the attention strategy, allowing a controlled comparison. In the methodology, we use GPT-2 with 124 parameters running on the single NVIDIA T4 GPU in the Google Notebook. For the dataset, we generated synthetic tests using the filter words. The real needle was in the haystack. The real needle was purple elephant sunrise, and the decoy was copper falcon midnight. But we tested six attention conditions. One used full attention, while the other one simulated the sliding window attention with different window sizes ranging from 512 tokens to 128 tokens. For every trial, we built a haystack, inserted the needle in it, and applied the attention mechanism for and ran the GPT-2 and classified output as the real answer and the decoy answer. We have majorly it contained the two experiments. First experiment is the failure boundaries, and the second one is the decoy interference. In experiment 1, we gradually increase the sequence length from 128 tokens to 1024 tokens to identify the exact failure boundary of the model. This result in 720 trials. In experiment 2, we introduced a decoy in our context, which was the golden falcon, and we introduced at a fixed position while moving the real needle across the context and the different depths. In the sequence length in the experiment 2 remains still at 896 tokens, and this experiment consisted of 600 trials. To ensure statistical reliability, we used Fisher experiment, copper person confidence interval, and also included no needle control. And now I would like to show the result of our experiment number 1. In this result of the experiment, the each sliding window attention showed the sharp failure exactly when the sequence length exceeded the window size, the context window size, and there was no gradual decline. There was sharp decline. retrieval drop directly from 100% to 0%. Meanwhile, full attention maintained perfect. The retrieval across all the length remain the same. This confirms that our experiment setup behaved exactly we expected. From the result of the experiment 2, the experiment 2 proceed our most interesting finding. When both the real answer and the decoy answer both were the present in the context window, the context and the input, instead of the real retrieval, instead retrieval of the real answer and what not done, or neither of the real and the decoy answer was not got from the GPT-2. With full attention, recall drop only 115% at 80% depth. However, when completing fact was removed using sliding window attention, recall increased dramatically from 85% to 100%. This statistical significance is very strong with a p-value below 0.001. And this slide explains why the previous slide is important. The model did not choose the wrong answer, but instead it often presumed neither of the answer from the both the neither decoy one and the real answer. In other words, the competing fact suppresses the both the inputs, the real one and the decoy. We also verified that the GPT-2 never guessed the correct answer from both of them. It was outside the visible context. This confirmed
I'm
that the
so
little
sorry to interrupt, but I'd request you to conclude your paper now.
Now, I would like to thank Dr. Ritu Soryal ma'am from Dronacharya Group of Institution to give us the opportunity to present our research paper in this precious conference. Thank you. I would like to answer any question if you have.
Thank you so much, Ahmad, for your presentation. Now we'll be moving forward to the next presentation. I would like to invite Kadambari Raghuram to present his paper on security, privacy, and machine learning in the Internet of Things, challenges, architectures, and applications in intelligent agriculture. You may start your
Thank you, ma'am.
presentation.
Am I audible, ma'am?
Yes, sir, you're audible.
Okay, ma'am. Ma'am, please allow me to share my screen.
Yes.
Hope my screen is visible, ma'am.
Yes, your screen is visible.
Okay, ma'am. Shall I start from here or from start?
You can start from where you left off.
Okay, ma'am. Thank you, ma'am. Actually, I am at the comparisons, ma'am. So this is our security validation graph. So where we presented our results over to you. So with respect to the agricultural, so so we have did some empirical validation, ma'am. So these empirical validation graph will provide our validation results, security validation results with respect to that. So on the left side, we can observe that what are all the results which are there about the replay attack, man in the middle attack, and the DOS flooding, RFA spoofing, and API fuzzing, and the overall weighted. Then have the security validation graph. So on the left, you can observe that all the categories achieved consistently with high detection rates, which vary with very low positive rates, false positive rates. On the right, the latency introduced by us by different stages of the security framework remains very small. The average latency overhead is only about 1.3 milliseconds, indicating that proposed security mechanisms introduce minimal computational delay. So our proposed framework successfully balances the strong security with real-time system performance. And with respect to the IoT growth context, the rapid growth of IoT devices and the enormous amount of data is generated every year. So as the number of connected devices are increasing day by day, to continue to increase, the importance of scalability security mechanisms will also increase. So future IoT deployments will involve billions of devices exchanging the sensitive information continuously. So this is what our IoT growth contest shows in this figure. Then machine learning performance, coming to machine learning performance, we discuss the machine learning performance of the evaluated models. So all five algorithms we have taken. Among all five, we have shown that gradient boosting achieved the highest prediction accuracy with an R square value of 0.94 and the lowest root mean square value of 2.14. So random forest also produced very good results with an R square error value of 0.91. So among the 7,000 samples we have taken. So this is the comparison in the graphical format. So we evaluated five different regression algorithms. This include linear regression, support vector regression, random forest, gradient boosting, and multi-layer perceptron. So linear regression was selected as a baseline model because of its simplicity. Support vector regression was included for modeling the nonlinear relationships. Random forest and the gradient descent were selected because ensembling learning methods generally perform well on agricultural data sets. So finally, we have a multi-layer perceptron neural net, a deep learning approach capable of learning complex patterns. The performance of these algorithms was compared using three widely accepted evaluation metrics, namely R squared value, root mean square error, and mean absolute error. This is the security validation results. After developing the proposed architecture, we performed an empirical security validation through controlled red team attack simulations. So five different attack scenarios were considered, namely replay attacks, man in the middle attack, all these things. So as shown, we can see that earlier we have shown the all the details with respect to that. Now this is a joint security performance analysis with respect to that detection rate and false rate and all. Detection rate is 98.4, false positive rate is 0.26, and security overrate is 1.3 millisecond. Graded motion inference was 4.1 millisecond. Total secure inference is 6 milliseconds. And we achieved federated GB achieved R square value 0.9. So future directions, we want to go ahead with the 5G and beyond the 5G networks and also to implement the edge computing devices. That is our future direction. So conclusion. So at last, we would like to conclude our presentation. We presented a comprehensive study of IoT security challenges together with an intelligent machine learning framework for precision agriculture. We propose a secure IoT architecture that integrates multiple security mechanisms across all the architecture layers. The proposed framework achieved an overall attack detection rate of 98.45% with a low false positive rate, while gradient quotient achieved the highest prediction accuracy among all evaluated machine learning models. The result demonstrates that robust security and intelligent analytics can successfully coexist within modern IoT systems. As a future work, we plan to extend our work by integrating explainable artificial intelligence, edge computing, blockchain technology, and next generation communication network to further improve the security, scalability, and decision making capabilities. Thank you very much, ma'am, for your kind attention. I'm very happy to answer if any questions were there. Thank you for the opportunity.
Thank you so much, Kadambari. I don't think there are any more further questions. Then
Thank you, ma'am.
now, I would sincerely like to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We'll be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would now also like to thank our session chair for hosting and guiding all of the participants. As a token of thanks, I would like to display the certificate on behalf of Team ICT for SD 2026 and Global Knowledge Research Foundation and partners. I extend my sincere gratitude for the session chair. Thank you everyone for your valuable presence. I would now kindly request all of you to switch on your cameras for a quick snapshot of the virtual conference. Can everyone please switch on your cameras? Everyone smile. Thank you so much, everyone. Stay safe, stay healthy. Thank you for attending this session.
Thank you, ma'am.
Thank you, ma'am.
Thank you so much.
Thank you. Thank you, ma'am.